Okay, so I think we are on air. Cool. Okay, so we're going to be talking about strings, factors, and regular expressions, not in that order. Who here has heard of Hadley Wickham and or the tidyverse? Okay, a couple of people. Okay, decent sample size. So he's like a pretty famous dude. When you know, you hear the word R, you probably associate it with a lot of the packages that he's developed. The tidyverse is kind of his little universe of packages. So a lot of the basic R concepts we teach here in our beginner lessons, or when we hold our software carpentry workshops, are based on a lot of his packages like dplyr, tidyr, ggplot, etc. But he's also made some other packages. And today we're going to be kind of exploring Stringer, which is a package that's good for pattern searching and kind of manipulating text-based data in R, and Forcats, which is a package that's used mostly for playing around with factors in R, which can be very, very difficult just using like base R. So does everyone know what I mean by base R? So when I say like base R, I mean R comes with certain functions and like functionality just on its own, right? You download RStudio, you install R into your computer. There are already some like functions and like things that you can do with it ready to go. And then you can add functionality by installing and downloading packages on top of that. So R already has some pretty decent like string searching, text searching functionality. So I'm going to go over that a little bit. The way we generally search through strings is with something called regular expressions. Regular expressions generally fall into two categories. So the first category, which you're probably going to be using a lot, is a group of characters that have like a certain meaning that like flag certain types of characters or parts of text files. And then the other kind of type of regular expression you can use is just something that's very straightforward, like the word itself that you're looking for, right? So you can use regular expressions to search a text file, change parts of the text file, locate very specific like lines, sentences, or words in the text file, do like numerical operations, things like that. Okay, so I wrote this down because I forget these little symbols every single time. So these are some regular expression characters. When I first saw these, I thought they looked like gibberish. But in fact, they all have a very special meaning in the context of regular expressions and regular expression functions. So in R, in regular expressions, a $sign doesn't just mean a $sign. It means the end of a string. And this little hat thing, I know there's like probably a better name for it, but I'm going to call it the hat, means the beginning of a string. So for example, if you had like, I have it right here, but who with a hat at the front and a $sign at the end, this is a regular expression, and what it's saying is like search for something that like starts with who and ends at who, right? And like nothing else in between is basically what it's saying. This little asterisk, which I'm just going to call a star because it's easier to say, is a wildcard. So for those of you who have like learned or used Linux at any time, it's kind of like it's similar to that. So I believe it refers to anything at all and more, right? So if I wrote like who star, I'd be looking for anything that starts with who and ends with whatever. The dot in R refers to any single character. So unlike the wildcard, it's like, this is saying we want just one character, not just like, you know, a bunch of characters in the end. So who this might find, might get you whom. So we also have like brackets and regular expressions. So if you write out who in brackets and then M, I did something funny. I reinstalled the packages. And then do 2 backslashes 1. What this is saying is take the thing that's in the bracket and like leave this alone. It's gonna make a bit more sense when I go through some examples. Anyways, the square brackets is a way of searching for anything that meets the criteria in the square brackets. So like, let's say you wanna search for any word that has any vowel, like at least one vowel. Putting all the vowels in brackets, square brackets like this, would search for a character or a string in your text file that has like any of those values. So what if you want to look for like this or that? Well, you can use this little stick. I'm going to call it a stick. We're going to use this little stick thing. And in like regular brackets, we can write, let's say we want to look for words that contain IE in them, or rather EI or IE. Or we want to look for words that have peace or war. I need that next. So that's a way of saying like or. I want to find strings that in whatever text I'm searching, I want to find either peace or war. And if one of these conditions is met, then my little regular expression is going to say, hey, we found this. So they're basically four functions, 4 most commonly used functions. There's another one that I think is regular. This one that we're not going to go over today in R, but the 4 most commonly used kind of regular expression functions in R are gsub, sub, grep, and grep-l. Okay, so I think to like the little symbols can get a little bit complicated with the characters. So I think to kind of explain or demonstrate exactly how this works, we'll go through some examples. So let's just create a like character vector with 3 fruits in them. In it, rather, and we're going to call it fruits. So we can see here that if we want to look at fruits, we have apple, banana, and pear. Okay, awesome. So sub, well, okay, gsub is basically a function for global substitution. So let's say we want to replace everything in this like list of fruits that starts with the letter A, right? So we want to find words that start with the letter A and replace A with something else. So the first thing we want to do in our gsub function is say what we're looking for in a regular expression kind of term, right? So we're going to do hat A. So this means look for any word that starts with A. And then the next argument we're going to give it is what we want to replace it with. So we could replace it with nothing. We could replace it with like a T. Let's just replace it with a T, see if that works. And then you need to tell what data set you're actually using, or what variable, what vector list, whatever you're working with here. So we can see here that like what it returns is it's found apple, because apple is the only word on the list that starts with A. It's taken A, and this function has said, okay, you want to substitute whatever this is for this, we're substituting it with T. If we just want to delete this T now, so we don't have tipple anymore, we just have PPLE, we could do this and replace it with nothing. Oh, that's interesting. Oh, I didn't say that. That makes sense. A. Okay, so if we want to like just delete the first letter, we could just do this, right? So we could do a little hat A, and then in brackets nothing, and what you're going to get is PPLE, right? So that's like one way you can use gsub. Okay, let's try to replace any letters that are any kind of character strings that are AN or AR with the letters BB. So how would we do that? For that, we want to use like an either or regular expression. So we would do G sub A, oops, yeah, AN, AR. Then what we want to replace it with, which is BB, and then again, fruits. So this function should affect any of the words in this list that contain AN or AR, and replace it with BB. So let's see what it does. Okay, so now we have, it found AN and AR in banana and pear, and it replaced those letter sequences with BBs. So now we have BB, BB, BA instead of banana, and PEB instead of pear. So if we want to use sub, let's take a look at how this is different. So basically the difference between sub and gsub, it's actually really simple. So what sub does is it only finds the first item in your list and performs your action on that first item and then stops. Gsub goes through all of the items in your list and performs this action on all of them. So I don't really know why you would want to use sub. That's like really just affecting like the first kind of item in your data set in your list. But like that option is there for you. So I find that less useful. But let's see what happens when we run sub instead of gsub. So the G, I believe, stands for global. So if we run this, okay, I don't know why it works on that. I believe this probably should. Oh, that's what it is. So what it's doing is it's only changing the first instance in each like string, right? Like in each. So if we had like a sentence as one of our like items in our list, then it would, you're right, it would only change AN, the first AN in that list, right? It wouldn't affect everything. Whereas like the global applies to like the entire kind of object itself. It's not like the list, it's like the items within the list. Yeah, that's correct. So if we had something like pair AR, and we reran this as fruits, then it should only affect the first AR. Yeah, so we now have pepper. Okay, so that's the difference between sub and G sub. My bad. Okay. So let's say we want to search for items. We're not trying to substitute anything. We just want to like find things in a giant text file or in a list of strings or what have you. For that, we can use grep. So let's say we want to find everything, every word that begins with A, right? So again, in our example here with fruits, that would just be apple. So all we do this time is pass it the argument hat A, which means things with that start with A. So A needs to be the first letter. And then we tell it where to look, which is fruits. And we see what it returns is like the index of where it is in this vector. So it's the first item. Okay, but like let's say we don't really want the index, right? We want the actual value because we want to see maybe in some giant data file what the word actually is that we have found that starts with A. I think what you can do is value equals true. I think that should work, yeah. So what that returns is if you set it to value equals true, it returns the actual string itself rather than the string's position. So it really sort of just depends on what you want it to return. And the only difference between grep and grep-l is instead of returning either the index of the item or items that you're string matching to, or the items themselves, the matched strings, what it does is it returns kind of a logical true or false. So let's try this again, but with grep-l. So what it's doing is it's giving us that vector back, but it's telling us in each case, is there a string match? So does starts with A match the particular string that you're searching? So in the first case with apple, we have true. In the next two cases, the two next fruits don't start with A, so we get false. So you can kind of see like these are like kind of small toy examples, but you can see where it can get pretty useful and pretty powerful. But these functions on their own aren't always that easy to work with. They can get a little hard and tricky. And Stringer is a really good way of doing a lot of like text searching, string searching, string matching, or pattern matching rather, in a really kind of like fast and simple way. So you'll sort of see what I mean in a minute. So like for example, grep, what if we didn't know whether in our data frame or list or whatever we're working with, we didn't know whether A was capitalized or not. And we just assume that it's capitalized. We're looking for apples, instances of apple, and we think, okay, it starts with a capital A. It's going to return integer 0. So the issue here is like we do indeed have a string that starts with A, it's just not capital A. So this is like case sensitive. So you can kind of deal with that with Stringer a little bit easier than you could otherwise using regular expressions alone. Okay, so month name, this is just like a default variable in R. It just gives the months in order. So I'm going to assign that to a variable, mth. Oh, and I also want you to load Stringer. So if you haven't installed those packages, please install them now. They're also, I think, available on the course event page. We're going to call the library Stringer. We have our variable month. Okay, so let's, again, take a look at month. So we have all the months. Let's say we want to convert the cases of all of these strings. So let's do string to lower. And this is going to convert all of the letters in every single string to lowercase. So if you want to do that, you can do that. But let's say we want them all uppercase, string to upper. Okay, now we have them all uppercase. Let's say we want to do the number of characters in each string of the vector. So this is going to give you the length of each individual string. So we would do str length, month again. So here it's telling you how long each of the words are, right? So May is like the shortest month. It has 3 letters. So let's say now we have this like list. Let's say we want to concatenate them. We want to turn it all into just one big sentence of months. Well, what we can do there is we can use string combine or string concatenate. I don't really know what it stands for. And then you can give it month as the first argument. And then you can tell it how you want to be collapsed. So you can just have like a space if you want all of these months to be separated by a space, or you could do a comma and then a space if you want something that looks a bit like this. Okay. So oops. I didn't do this. Okay, so now this is just one string, right? Like you see there's only one index here. Now this has all been turned into one big string. So we've collapsed all of these and we've used like a comma and a space as the separator between them. You could also do something like, I don't know, you could put whatever character in there you want. So there you go, if that's how you want it to look. You can also take like a subset of the months based on regular expressions. So let's say we just want months starting with J. We could do string subset. And then you would, again, just tell it what data you're using. And then starts with J. We have January, June, and July. Okay, awesome. What about months ending with Y? So again, pretty easy. Dollar sign is the end of something, so we would do Y dollar sign. So these are all the months that end with Y. Okay, but let's say we want to do months that contain one of many letters. So for that, we would use the square brackets, if you remember. So let's say we want to look for months that contain either S, N, or D, but only lowercase. For that, we could do, oops, string subset again. We're still going to use month, but this time using S and D in brackets. So what this should do is it should loop through all of these months. And if any of them contain any one of these lowercase letters, then it should return those months. Okay, so only January, June, and August contain either a lowercase s or a lowercase n or a lowercase d. So what if we wanted to search for months that had s's? Like, let's say we wanted to find September, but September in this case is uppercase, right? So for that, what we could do is we could convert all of the letters to lowercase and then do a search. So that's like one easy kind of way to do it. So you could do string to lower. And string subset. Okay, so we're subsetting string to lower month. So Now we have month in all lowercase is our kind of data that we're pulling from. And then our regular expression is square brackets SND. So this should return September if we've done it right. Indeed it does, right? So now it returns also December. December starts with a D. So that's like one way to handle cases using stringer. So because stringer was made by Hadley Wickham and is kind of part of the tidyverse universe, you can use the pipe with it. So does anyone know how to use the pipe? Do I need to explain? Okay, awesome. So this is like kind of an example of how you would pipe commands or stringer commands into each other rather than just sort of doing what I just did, which can be a little bit confusing to read, or you can confuse yourself sometimes. So command, oops. Oops. So this is basically doing the exact same thing as the command above, right? Since returning the exact same strings. So string detect, that's pretty much exactly what it sounds like. So it converts like the presence of a string that matches your regular expression to logical. So you can use this for filtering, subsetting, whatever. So let's use our fruit data set, and we can do string detect and then fruit. And then we want anything that starts with BE. Okay, so there's actually a fruit variable in the stringer package. So we're not actually going to use the thing we made, which is fruit. So we're going to use fruit with just a T, no S. So if you see this has like a really long list of fruits. So let's try to look for things that might be like start with berry. Or just BE. And let's see what we find. So stringer detect fruit and starts with BE. So what it returns is like a list of like Boolean values telling us for each position whether the string matches our regular expression. And in this case, it looks like we have one case that does, which would be 1, 2, 3, 4, 5, the fifth case, which is probably gonna be somewhere way up here, which is bell pepper. Okay, so bell pepper matched our, apparently that's a fruit, that like matched our regular expression. You can also use stringer to find out like the proportion or number of fruit with like that match your regular expression, or in this case, in this example, like fruit with at least one vowel at the end of the string. So we can do stringer detect fruit. And we're going to do the same thing that we did earlier with the vowels, A, E, I, O, U. And we're going to put a $sign. So it's what this is saying is it has to have at least like one of these things at the end of the string. And then, oops. And then we're going to type that to the function mean. This is just going to tell us like the mean number of fruits or the percentage that end with at least one vowel. Okay, so you might be thinking like, where did I get a number from these Boolean values? Well, in R, true is represented as 1 and false is represented as 0. So what this did was it took the mean of all of the numbers underlying these Boolean values and said, okay, 35% of the strings in the data set fruit end in a vowel, at least one vowel. So if we were just to do string detect, you can see maybe about 35% it looks like do indeed end in a vowel. Okay, so let's go to stringer replace. I'm not going to go over the stringer split. I'm going to move on to the next package after this, but this information is all going to be posted online. So stringer replace is pretty much identical to sub or gsub. So let's try to search for any month that starts with a J and ends with an E and replace the middle with something. So we could do stringer replace. We're giving it month. Now in this case, we want it to start with, oops. Okay, so we're saying only J. Anything in between, so like wild card in between. And then ends with only lowercase e. And then we have to say what we want to replace it with. So this is saying, all right, the first thing. And then in between the first thing, we can say hi or hello world. These two backslashes too, this refers to this like second kind of expression. This backslash one refers to this first kind of regular expression. And then what you're putting in the middle is what you, so you can on that. And it looks like June has been replaced with J hello world duh. Okay. So one thing that you can't do in base R, or that you I think can do in Python, although I'm not really super familiar with Python, is you can like split strings up by specific characters. So string split is like a useful function for that. So it actually creates a list. So you could do, so sentences is a native like data set that I think comes with this package. So just as an example, if we wanted to split like the first sentence in this data set into individual words, we could do, okay, string split sentences. Okay, so this outputs a vector. Oh, I should be, sorry, this did it for every single one. So if I just want the first case, the first sentence, then I do this. So the birch canoe slid on the smooth planks. So if I were to just subset the first item in sentences, it would be a whole sentence. But if I throw it into stringer split, it splits it into a vector with the words on their own individually. Okay. So the rest of the information here just sort of explains how to like remove periods from this, things like that. You can split this into individual letters instead of individual words. Okay, but what are factors? So who here knows what a factor is in R? Hands up. Okay, do you want to explain it?
I don't know.
Okay, so it's basically a data type. It's its own data type, and it's kind of a special data type. It's almost like you can think of it as kind of like a category, I guess. But it's generally used in statistical models, or factors can also be used in like graphing, like in ggplot, making graphs. So factor variables are basically like ordered categorical variables. So they're like categorical kind of groups. I mean, yeah, they're categories basically with numbers underlying them. And they like, if you have a factor variable, the factors within it are listed in a certain order. So let's call library forcats. Okay, so this is what month looks like. As this is the structure of our variable month, right? So as of right now, it's a character vector with 12 items in it: January, February, March, et cetera, et cetera. So let's say we want to convert these to factors. So using base R, we would use the as factor function. And it does the exact same thing as the as factor, but using an underscore rather than a period function in forcats. But what you're going to notice is there's a bit of a difference here. So oh, that shouldn't be, that's not actually how it should have worked. Maybe that's not the case anymore. Well, it used to be the case that this would reorder your factors alphabetically, but it doesn't look like it does that anymore, which is kind of interesting. Oh, yes, it does. So 12 levels: April, August, and then it ends with September. So you can't see it here, but basically what the as factor function does is it orders your variables alphabetically. So if you were to make a graph and do like a bar graph and do like, I don't know, amount of rainfall by month, what would happen is if you use the month variable and it's like a factor variable, from left to right, you would be looking at the months alphabetically. But you probably don't want to do that, right? Like you probably want to look at it in order of like time when the months like come up: January, February, March, April. So if you use this as underscore factor, this function from forcats, rather than like the base R function with this dot, it doesn't reorder your factors. It keeps them the way that they were in the list. This is actually like kind of a useful thing for making graphs. If you can kind of like imagine you're making a graph and you want your like rainfall month bars to be from January to, you know, December rather than from like April to September. Because that makes sense time-wise. So we have time for like a couple more examples. So let's like make a variable that has multiple instances of each month. Here we're gonna have month 10 to 12. Oopsie. Month. So what this is going to give us is a vector with like a bunch of repeats on the months. And to give us, oh, I should have done this. Let's see. Oh well, whatever. 2. So here we have this like long list where we see that we have like repeats. We have like multiple Decembers. We have multiple Novembers, et cetera, et cetera. But this is still, we want this to be like a factor variable, right? So you can actually order, let's just make sure. Anyways, you can actually order these, even if they're in factor form, in different ways using like forcats commands. So one thing you can do is order by frequency. So you can order your factors by like how often they appear in your data set. So what you can imagine if you're doing a graph is maybe you want to order, like you have like you want to graph instances of something, right? Like instances of your factor variable, and you want it to be ordered from like most to least. This would be like a good way to do that. So you could order it using this command, oopsie, fct in freak. Then it orders your levels by how often they appear in your data set, going from, I think, like most common to least common. So May only appears once, so it's at the end. December is like the most common, so it goes at the beginning. So again, if you kind of like use this to like reorder your factor variable, then if the levels are in this order, that's how they're going to appear in your graph. So you can also do this function called fct in order. So I mean, this does basically the same thing. So it's like this orders it by which items first appear. So if December 1st appears in the list, then the first level of your factor is going to be December. If January appears second in your list, your second factor is going to be your second level of your factor list is going to be January, and May is like the last month to appear on the list. So that's why it comes last here. You can also sort of count the number of levels within a factor. So that's like pretty simple math that you can do. One, two, sort equals true. So we want the counts of like how often our months appear, and then we want it in order. Again, you can see why this kind of information might be useful for like graphing or graphical display purposes. So December appears 5 times in our month 2 variable. May only appears once. So you can see it sort of orders it by number first, and then I believe it orders it by if like it's a tie, it gets ordered by like alphabetically after that. So one really useful thing that this package can do is, let's say you have a really big data set, and one of your factors is like ethnicity. So I'm a psychologist. A lot of the times when I do a survey, I ask people maybe their ethnicity or their, annual income bracket or something like that. So if you get like a lot of rare cases, sometimes it makes sense to like lump them into like an other category. So let's say, most of my sample is one of 4 ethnicities, and then there are a few, like very few cases of a few others. And I want to create an other group because statistically it just makes sense to collapse those cases together. So you can do that with Concatenate too. So we can convert them into an other factor category, which is really, really useful for large data sets where you have like maybe user input, things like that. So it's like a really quick way to group uncommon values together and not just have like a million different factor levels. So it's called, here we go. Again, we need to give the data set. And then we have to give it a number. So this number is like how few times it has to appear for it to get grouped into that other category. So if it's once, we're only grouping things that appear once into another category. If it's 2, it has to be like 2 or less instances to be grouped in that other category. So let's try 1. I think May is the only month that appears once in our data set. So this might end up in the other category. So let's see what that looks like. Oh, December is the, okay. Okay, I'm not quite sure why that didn't work. December, everything appears more than once. That's it. Okay, well, that's kind of strange. I'm not exactly sure what I did wrong there, but you can get them renamed also. So let's try this again. So you can do a proportion also. So if you did 0.1, that would be like 10% of the sample. Then you can tell it what you want to rename it to. Say NA, or we'll say other month. Okay, so it worked this time. I don't really know what was happening here. Maybe we could try prob. Okay, so here, if it's not making up more than 10% of the sample, I guess December and November are the two most commonly appearing months, then the other months get lumped together in other. So this works with proportion, but for some reason it's not working for me with the number. This should work though. Anyways, here we have, again, proportion 10. So anything that, any month that doesn't comprise like 10% of your variable, of your sample, is going to be assigned other month. So let's see what that looks like. So, I mean, this doesn't look that much better, but everything that is like appears less than 10% of the time in the sample got labeled as other month. So like, let's lower this number, or let's increase it maybe to 20%. There are no months that appear like take up 20% of that sample, so they all got labeled into the other month group. So this is kind of useful if you have like this idea of like, okay, if this one particular ethnic group, or like maybe this one particular socioeconomic status group, they only take up maybe 5% of my sample, you could say, you know, they only take a 0.05 proportion of my sample here, so I'm just gonna lump all of them into like another category together. Okay, so finally, I don't know if any of you have ever tried to rename factors in R. If you have a factor list on a variable in R, and let's say there are like 10 factors, to rename it, you have to list all 10 factors in a row and then change. Even if you're only changing one, you have to list all of them, which is kind of a pain. So Forecast has a really, really easy function for renaming levels within a factor. So if you do fct read code 1, 2, but let's say we want to rename January as Jan and February as Feb. We'll actually just click enter here. Jan equals January, equals February. And my birthday's in August, so I'm going to rename August Lindsay, my month. So let's do that. No marbles. Oh. The way around. Here we go. Okay, so now all of our instances of January have been relabeled Jan, all of our instances of February have been relabeled Feb, and all of our instances of August have been relabeled with my name. So that's like actually a lot easier than typing out every single level of the factor, even if you just want to rename 1 or 2 or 3. And the other good thing about this is you don't have to remember the order of the factor levels, whereas if you're using base R code, you actually do need to remember the order, which is kind of a pain. So one thing I'll say about regular expressions is that they're like very similar in every language. The functions that you use to do like pattern matching and like exploring text files in R, you know, are different than they are in other languages. So Stringer is a really good resource. Base R has some good functions, as we saw earlier. Yeah, there are a lot of resources and just like online YouTube videos and tutorials on regular expressions and how to use them. They can end up saving you a lot of time in the end. So I've used regular expressions to, like one example was I did automated image counts, like I had a microscopy project. So I did automated image counts on, let's say 2000 like microscope photos. And basically I wanted like the file name, I wanted to remove the file extension and just have like the animal subject as like the subject name. So I just use regular expressions to get rid of like the dot JPEG or whatever. So you can do a lot of really easy things like that. And it can save you a lot of time for really simple tasks that would be otherwise super, super repetitive. So here are some more resources on factors and forcats in particular. And here are a couple more resources on strings. So Stringy, I think Stringy is what Stringer is based on. I think Stringy has a lot more functionality, but I've never used it. So if you really want to get like heavy into regular expressions, that's like something else to check out. So I think I'll probably wrap up there because it's about 7:05. But if any of you have any questions, please ask. Let me know if there are any like parts of regular expressions or Stringer or forcats that are still kind of unclear. If you have any questions about what you think you might want to use it for, feel free to like ask those now.
I love the bar with the G sock.